Now children, we will do some questions based on ionization enthalpy. First is lower IE value in the pair. Which will have the lower? Chlorine and fluorine, they belong to same group. F is smaller in size, Cl bigger. So it will be easy to pull out electron from Cl as compared to F. So naturally, answer will be chlorine. Out of chlorine and sulfur, they belong to same period. So chlorine is towards right side, means smaller in size. Hence, sulfur will have lower IE value, right? Because chlorine is smaller in size, force of attraction will be greater, difficult to pull out electron. Hence, sulfur will have lower. They are asking us lower, not higher. Out of potassium and argon, same period, argon extreme that side and potassium extreme left hand side, quite big in size, and inert, they have extremely high values. So naturally, potassium will have the lower value, right? Out of krypton and xenon, they belong to same period. Helium, neon, argon, krypton and then xenon. So krypton is above, means smaller in size, and xenon is below. So naturally it should be xenon, because you have been taught the chapter atomic structure and you have been taught some simple, you have been given some simple idea of periodic table. So you should know, and this sequence for common elements you should know. So it is xenon which will have the lower value, because helium, neon, argon, krypton, xenon. So xenon is lower, bigger in size, hence this will have the lower value. That was one question. Then come to first question number 3. A, B, C, D, these elements are given to you and these are the atomic numbers. And they are asking you arrange in increasing IE. So A will be, A is like this. A is 1s2, 2s2, right? B is, so I am writing here just 1s2, 2s2, 2p1. C will be, now you can understand, 2s2, 2p2. I am not writing 1s2. And D will be 2s2 and 2p3, right? 1s2 is understood. Or if you want to write, you can write 1s2, 1s2. So 2 to 4 and 3, 7. Now see children. From here to here, if you move, fully filled, and this is 2s2 and this is 2p1. Naturally, if we see size factor, B is smaller, but A is the case of 2s2 and this is 2p1. So this should have higher value. Out of B and C, it is p1 and p2. There's no special case of half filled or fully filled. So we can say C will be smaller in size, will be moving this side, hence C will be having greater value. And this out of C and D, you see D is having P3, special case, half filled, very stable, hence D will have high value. So if they ask you arrange them, they ask you arrange them in the increasing order. So we can see D will have the highest. After D, we should have C. After C, we should have A, and then it should be B, right? Because D was having highest half filled case, then after that C had to come. It's not that B will always be having higher. I told you when we have the case of half filled or fully filled, they have higher value only as compared to their neighboring atoms. So after D, C had to be there, and out of A and B we had seen A had to be higher and B was the lowest. So this is the second question. Now we come to third question. Now we go to second question. Children, they are giving you these values of the first IE and second IE. There are 4 questions. There are 4 values given to you. These 4 values are given to you. These 4 values are given to you. Now they are saying you have to find out most reactive metal, most reactive non-metal, or say reactive non-metal, noble gas, and metal that forms a binary halide. Now children, out of these 4, so naturally 1 for each. When they give you a question of multiple choice, like this, or anyway multiple choice, you have to take the most appropriate choice. Out of those only, not that this is not there, this is not there. What all is given, out of those you have to get the most appropriate choice. So we have to see first most reactive metal. So whichever has the lowest value of IE will be our most reactive metal, because what are metals? You know from lower classes, any element which has tendency to give out electron or electrons is called a metal. Or say metals are electropositive elements, you all know. So whichever can give out electron easily will be a reactive metal, because metals are electropositive elements. They give out electrons. So whichever gives out electron easily, the fastest, will be the most reactive. So this has the lowest IE value, means our this metal number 2 should be the most reactive metal. I hope you have understood. Then comes reactive non-metal. So certainly now this is gone. Now out of these 3 we have to see these values are there. Now this value and this value is quite high. It means they should be non-metals. Remaining what all is there, this you have to have some idea, because they are also asking us a reactive non-metal. So non-metals, if we see, they should be out of any these 2. But then you see here children, they are also asking us noble gas, means out of these 2 we have to sort out, one is noble gas and one is reactive non-metal. Values you don't know, I don't know, and we need not know. We just have to have a comparative account. What all is given to us, out of that only we have to sort out. So out of these I can see they have got very high values. So they should be noble gases. So this should be noble gas. So certainly the reactive non-metal should be this one, 4th one. Because we know we move left to right, the non-metallic character increases and IE value increases, but the highest is for noble gases. So the non-metals moving left to right, they are there, they also have high IE values. With the result, our 4th should be the reactive non-metal. Then you see they are saying a metal that forms binary halide. So this was our inert gas, this was our reactive non-metal. So this, if you see children, this is there. This gives us an idea that it must be having valency 2. Most reactive metal in a period is alkali metal. So first electron took out, this value was required. But when it took out second, the value was suddenly very high, 7,000 something, you see. Why children? Because it took out 1 electron from the outermost shell. Now it became very stable and you had to go to the second shell. Use. You see, this is alkali metal. Alkali metal, suppose it was, say, atomic number 11. Means 1s2, 2s2, 2p6, 3s1. Say this S1 gone out, you require this energy, no problem. But now when you want to take out second electron, when this is gone, it is P6, very, very stable. And you see so high value. It means this can be only an alkali metal, because now it is having a status of what? Almost a noble gas, octet complete. So this shows it was the metal having valency 1. Valency 1. Valency 1. And here, so naturally this was inert gas, this is non-metal. Now see here, whichever metal is there, I don't know. We took out 1 electron, fine. Second electron, the value had to be higher, but not a very high value suddenly. So ultimately, this could be the one which can show valency 2. I'm again saying, no one knows value, neither you nor me, and we need not know. We have to have a comparative account. We have to sort out only out of those. So first electron gone out, second. This shows it must be having valency 2, and when the valency is 2, then only it will form a dihalide of the type, say, MX2. MX2. So this will be our 3rd element. Element will be 3rd, which will form the halide of the type MX2. So this was a little tricky question. Children, as I told you, you always have to sort out of the given choices. I did not know, but I came to know this has the lowest IP, so this should be the most reactive metal. I sorted out. So number 2 most reactive metal. Then it was, they were saying reactive non-metal. So they should have high values, non-metals. Now either this or this, fine. I don't know, I'm not very sure. But then they said also a noble gas. It means out of these two, one is noble and the other is inert, a normal reactive non-metal. So out of these values, only this could be the noble gas because the highest value. So noble gas number 1. Then this should be the most reactive non-metal because it has high value but must have been on the right side because it has to have value lower than noble gases. So comes here. And then this first electron gone out, this value, second gone out, this value. But of course high, but not that sudden rise. And here it was much higher even than your inert gases because now you're penetrating the second shell. You're going deep in. One electron gone out and then it was from the inside and that too inert shell and octet complete, hence the very high value. So this in no case can show valency 2. Only this was possible. Again, I'm saying the values were not known to me. It's only out of those given values we have tried to compare. Children, this question is in your book also. So at home, you will open your book. Points I've explained you, but the questions are given in your pink or say red ink. Please try those questions again. Although I've explained you, but you'll be getting this type of questions in your coming test also. So this is all for your ionization enthalpy. Do revise and try those questions again which are given as the solved examples in your book. It's a must. You can always expect questions for 2 to 3 marks or 2 marks at least in your paper from this topic only, ionization enthalpy. Very, very important property and I hope it is clear. I discussed all. You just revise at home, please. So this is all for today. Again, I'm telling children, you will complete your notes and once the chapter is over, you will have to submit it to me and Rashmi ma'am also. Section wise. It is a must. You are being marked and if you will not submit, we'll send you reminders but ultimately you will suffer. So please take my words seriously. Note down everything. It is there, simplified form and try and update your notes. Keep the copy ready because every time you cannot study from video, right? Please. So I stop here. This is all for today. Thank you.